Yo.
Eguli, 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 egg.
What's up, Jason? What's up, Moku? What's up, Desu? Mewing? No, I don't mew. Actually, I don't know if I do. All right, chat. All right, let's get it. T-minus 23 days. Time is going by fast, a little too fast. Let's get through as many leak code problems today. I was doing this question off stream. And I feel like I keep seeing questions where I just don't have any prior knowledge to solving a question like this, but I did recently learn about what a union find is, so I guess just another thing to learn. What's up, Lapis? Yeah, 3 weeks, a little over 3 weeks. It's already been like a week. So fast. Time is going by a little too fast right now. I'm gonna study systems design again too. All right. Yeah, so this question, like, you could do it with a DFS. So just trying to figure this question out, which I kind of understand now. Time is ticking. I know I'm feeling the pressure, but to be honest, I think I stopped I guess like kind of grinding a lot of leak code once I get to like 100 questions. So I believe I'm at like 60 something, 64. It might be a little more than this actually. But maybe once I get to like 75 or 100, we'll see depending on time. But I think I want to get to like top 100. Get to top 100 and then like basically speed run through all of these like every day, or like, you know, every other day or something. I gotta study a crap ton of systems design too, so oh man. Okay. Also, I realize I can talk to ChatGPT now.
Hey, what's up?
Hi there.
Hey there.
Hi, glad to meet you. I think we're going to do great work together.
Hey, what's up, man?
Hey there. Not much, just here and ready to chat. How's it going on your end?
I'm a little nervous. I feel like I'm not gonna be ready for my interview next month.
Totally understandable to feel those nerves kicking in, especially when it's a big interview like the meta one you've been prepping for. But you put in a lot of work, and you've been drilling those coding problems and system design concepts for a while now, so trust that you built a solid foundation. If you want to talk through any last minute stuff or just get a little pep talk, I'm here for it.
I have about 3 weeks left. Do you think I have enough time to cram?
Absolutely. 3 weeks is actually a pretty solid chunk of time. I mean, you've already laid a lot of groundwork, so this isn't like starting from scratch. In these next 3 weeks, you can definitely fine-tune your weak areas, maybe do some mock interviews if you haven't already, and just keep practicing consistently. So yeah, you've got enough time to cram and polish things up.
How much time should I be spending on systems design per day?
Yeah, so for system design, I'd say it's more about quality than just raw hours. If you can dedicate maybe an hour or two each day to really focus on one design problem, that's pretty solid. So maybe you pick a common system design scenario each day, spend an hour breaking it down, and then maybe spend a little time reviewing your approach or comparing it to some reference solutions. Over the course of 3 weeks, That's going to add up nicely, and you'll get pretty comfortable with it.
Is it okay if I just look up the solution for like most of the problems? Or should I try them myself?
It's definitely a balance. I think it's totally fine to look up solutions when you're stuck or after you've given it a real shot yourself. The key is to try to work through the problem on your own first, because that struggle is what actually helps you learn. But if you hit a wall, peek at the solution, understand it, and then maybe try to implement it from memory. That way you're still getting the benefit of learning by doing.
All right. Sounds good. What about coding? How many hours or how much time should I be spending on coding per day?
Yeah, totally. So with coding, it's kind of similar. You don't want to burn yourself out, but you also want to keep a steady rhythm. I'd say if you can do about 2 to 3 hours of coding practice a day, that's usually a sweet spot. Gives you enough time to work through a couple of problems, maybe review some concepts, and still have time to digest it all. And of course, if you ever need a break day in between, that's fine too. It's all about consistency over time.
Hi, glad to meet you.
Wait, hold on. I thought there was a setting.
Hi, glad to meet you. I think we're going to do great work.
I thought there was a setting where you can make this guy smarter or something. Maybe not. Could be wrong. Yeah, you could change the voice. I like
Hi, glad.
Hello, it's lovely to meet you.
Hi there, nice to meet you. I'm excited to help you get things done.
Hey, I'm ready to hit the ground running. So if there's anything you'd like me to focus on first, just let me know.
Hey, it's great to meet you. How's your day going?
Hey, how's it going? I'm looking forward to working together.
Hey, what's up? Feel free to ask me.
Hi there. I just want to share how thrilled I am to work with you.
Hey there. I've got a really great
Hi, glad to meet you.
I think this one's the best one, chat. He hit the classic, hit the ground running. What a cornball. Do you think I should grind the top 75 or top 100 meta tagged questions?
I think aiming for the top 75 is probably a good sweet spot. If you cover those top 75 meta tag questions really well, you're going to get a very solid grasp of the patterns they tend to ask. And honestly, quality over quantity. If you feel confident on those 75, you'll be in a great position. If you have extra time and want to push to 100, that's cool. But 75 solid is definitely a strong target.
All right.
So yeah.
Sounds good, sounds good.
Awesome. Glad that sounds good to you. Just take it step by step and keep that steady momentum. And of course, if you need any more tips or just a pep talk along the way, you know where to find me.
How can I make my brain work more efficiently instead of just dumping more hours into studying?
Yeah, that's a great question. Honestly, it's all about working smarter, not just harder. One big thing is making sure you're taking breaks, like using techniques such as the Pomodoro method, where you study for maybe 25 minutes and then take a 5-minute break. That can really help your brain reset. Also, things like making sure you're sleeping well, staying hydrated, maybe even getting a little exercising can keep your mind sharp. And sometimes mixing up what you're studying or changing the way you practice can help your brain stay engaged and learn more efficiently. So yeah, it's a mix of good habits and a little bit of strategy.
Okay, sounds good. Sounds good. Thank you.
You're very welcome. I'm glad it helps. Just keep it up and trust the process. You've got this. And of course, if you need anything else, just give me a shout.
Australian voices, I love. I feel like the Australian accent is the most pleasing to listen to. I don't understand why, but all right, this question. Okay, let me go through this question again. I kind of went through this question, but it's a new concept. I feel like I haven't understood before, but basically, this question is basically saying, given a list of accounts and each element is a list of strings. Here's my Excalibur draw. Okay. So from here, given a list of strings, right? So the first element is always a name. So we're gonna have like let's just say J, and then everything after that is gonna be an email, right? So we could just say like a@.com, and then b@com, and then there could be another J, right? And there could be another a@com, and then there could be like a c@com, right? So basically, this is saying if there's if there's two accounts that belong to the same person, I think the whole thing belongs to the same person. I think that's like the whole point of this problem. Two accounts definitely belong to the same person if there is some common email to both accounts. So basically this is saying like, so this, like the first element is always the name, right? And then everything after that is emails. So this question is saying that anytime we have a connect, like a duplicate email from two different entries with the same name, so this guy's name is both J, then we basically merge this into one entry with J, A, B, C. That's what they want. Because the A's merge, then the B, and then the C. That's how they want it. That is the point of this question. Okay. Now that I've solved this problem before, apparently anything that has to do, so like I guess to visualize it, you're supposed to visualize this actually as like a graph problem. So like A, B, right? This belongs to John or whatever, J. I don't know what his name is, but this belongs to J, right? But then J also has A and C. So this same A also has a C. So anything that has to do with like connections, you're just supposed to know that this is a union find question. That's like the intuition. Now you can technically solve this just by doing a DFS. And I initially tried doing this through DFS. So basically the approach to DFS it is you would have a dictionary, two dictionaries, I believe. So two dicks, right? Where one is mapping, basically you're creating like an edge for everything to the parent, right? So everything for the first email, like everything subsequent to it. What did I just do there? Everything subsequent to it gets mapped. Oh wait, I swapped. Oh, I see. So like, let's say we had, okay. Let me just erase all this. Make it simpler. And let's say, start again. Let's just call this A, okay? And this A person has A, B, C, right? So what the first dict is gonna do is it's going to map all of the nodes to the parent, basically. So like all the edges are gonna point to the parent. So like A is going to point to B, and B is going to point to A. And then C is also going to point to A. And A is going to point to C. This is a disjoint graph. So I think that means like directions don't matter. They're pointing in both directions. So map emails. Emails. But this is to note that email of 0 is going to be the key, and then an array of emails, right? That's going to be our first dictionary. The second dictionary we need to create is going to be who does the email belong to, right? So for the we're going to have it based on email is the key, and then the name is the value. So in this dictionary, it's going to be like A belongs to A, B belongs to A, C belongs to A. This is going to be pretty simple, I think. Okay, so why don't we try this again? And I'm going to just push this all to the lower so I don't cheat. So step 1 is going to be create the dictionaries. And then what we're going to do after that, we're going to have to just DFS through them, right? Once we create our connections, we're going to have to just DFS through them. And we're going to maintain a visited set. DFS plus visited set. All right, see you, Jason. So we can create the dictionary, which we'll just call and just call email graph. But this is actually going to be a default dict of a list. It's going to be a bunch of lists, and then name emails or email name. It's going to be initialized as an empty dictionary. And we're going to basically go through for accounts in accounts. And like we said, in this problem, the first thing is going to be the name. So name is going to be account of 0. And the emails are going to be the account from 1 to the end. That's the way this problem is set up. And from there, we're also going to need to loop through for email in emails, right? And then from this point on, we said that we were going to create a dictionary, right? So a dictionary of lists. So actually, we can't say this. We need to actually go through everything after the first element, right? Because we said that the first email is always going to be the parent. So this is first email is the parent always. So if that's the case, if the first email is the parent, then that means for we can just call this I in range of 1 to the length of emails, right? Then this will give us access to everything from the first to the end. And then at this point, all we're going to do is we're going to say email of graph, and the key is going to be the emails of 0, right? The first right? think this is right. We're saying the parent email. So johnsmith@mail.com is going to be the key, and we append this. We append the emails of I. And we do the same thing. We map them bidirectionally. That's the reason why we do this. Because basically 1 points to 2, 2 points to 1. That's what we're saying here. And then for I in range, all right, so that's the email graph. And then for the names, like we said, for every email, so email name of 0, no? Is equal to email name. So email name is mapped to whatever. Okay, so everything we do here, we have to say name, email name of the emails I to the name, right? Is that right so far? Let me double check. Actually, they do 2 loops. I feel like that's inefficient, no? Could combine them both. Email graph. What the freak? There has to be a better way to write that. It's a little confusing. Can't lie. Name emails. Like, this is so unintuitive to me. I feel like this setup. I feel like there has to be a better way to do this. Like, this one is setting up the email to name, right? Email name, email graph. This email graph email just initializes it, I guess. But like, it makes sense. So like, we could technically do it here, right? Email graph. I mean, there's like an edge case, right? Like in the case that you do, like you only have the parent and there's no other emails, right? For example, you can have an input that's like B and then just have one thing here, right? And if you just have one thing, then this logic never creates the key for this dictionary, which I don't know if that is really. Yo, Kaiti, thank you for the raid. Appreciate it. We had a good stream. Not sure if you're also studying or do study content, but welcome in everyone. So I guess this is just to initialize, right? This email graph of no, but study streams are calm. Yeah. What do you do? What do you do for stream? Are you a gamer? Email graph. So we're basically saying the emails of 0 is our key, right? This is basically just to initialize. Initialize key for the graph. Oh, you play Valo. How's Valo today? Was it stressful? Good games? Dubs? Crash out is always classic. I still need to finish my battle pass. I'm so behind, low key. I have, what is it, 6 days left? And I still have... Chat, am I cooked or no? I still have like about 100... Dude. It's over. Customs? Oh, that's chill then. Must be a good time though, probably with friends, right? Okay, so email graph, emails. Okay, so apparently we need this line to somehow know to just initialize, but then at the same time, yeah, I'm cooked. Okay, you know what? I could write this instead like this. So for I in range of the length of emails, right? So then if I is greater than, or if I is 0, this is jank? I don't know if this is jank. I don't think it's that jank. If I don't know, is it jank? I don't know what's better practice or not. But like, why go through a double for loop when you don't have to? You know what I'm saying? Because like, technically, that is a double for loop. Because like, we could just do it this way instead. Because if I is greater than 1, right? Then all we just say is email graph of emails of 0 dot appends emails of I. And then again, like we said, we're gonna do this bidirectionally, chillin'. And then if it's 0, then that means we need, oh, and also let's not forget to say that, actually in this case, I think we always add it. So this only applies to those things, right? But for the name, so email name of the emails of I is equal to the name, right? And then in the else case, we're saying that this I is equal to 0. So just in case, let's just initialize email of graph of emails I, which is the same thing as saying just this, right? Just to, like, this is basically just to initialize in case there are no other emails. That's like the point of that line, right? So now if we, so is this, is this good so far? Oh shoot. Right. Silly me. Okay, so this should actually be 0. Alright. What do you think now? How is this now? You're very close, but there's still a tiny bug. Just referencing a key doesn't initialize it unless it's accessed meaningfully. Okay, you're saying that I don't need it now. Okay. This thing is being bipolar, because... Okay, let's just take this out. Okay, so this guy is saying all we need is this then. How is this? A redundant condition check. I don't understand. But isn't this just looping twice? Looping the emails twice is what I have actually worse than what you suggested here. Okay, that's literally what I did, no? Okay, sure. I put it after. So this is what this is saying. So this. Okay. Alright, let's move on to the next part, right? This part, I think all makes sense. So basically we mapped all of the graphs as well as the emails to their names. Right, so now we have to DFS through all the okay, so at this point we have to DFS through what? Is it the email graph or the email name? I think... Not to cheat, I don't know. But why do I not know though? The email, okay, so the graph is basically the graph is the email graph. The graph is the name. Do we loop to the graph or the name? That's the question. So basically, will just going through the names help us find? Or will I have to go through all the... Four common accounts. In the graph, we'll have all the edges, right? I don't know. I'm stuck. I have no idea how the DFS would work. DFS to find the connected components. We're DFSing through every email in email graph. Yes, so we're going through every single email key in the email graph, and then we're just DFSing through every single email. But how is that gonna help us? So like, okay, we're gonna say like John Smith, right? John Smith. Then we know that John Smith also goes to John, New York. But then what? And for Nay if Nay's not visited. The visited add path append for Nay in email graph. If the neighbor's not visited, then we just DFS again. So like this first run, we'll just add John Smith in New York, right? But then let's say we run it again. This visited set, I guess it's already there. But then we res append. I don't get it, bro. I don't get it. Okay. For each component, sort pre. Can you help walk me through DFS part? I don't get how I'm supposed to DFS through. Let's walk through the DFS. We want to visit each connected group of emails, collect all emails in that group using DFS, sort them, and prepend the name. Why DFS works. Because it's already, oh, I see. We already did it. That's why I think. Oh, I see. This technically, I think, already did all the work for us because we mapped it into a dictionary. Because what this is saying is like John Smith at email, like mail.com is the key, right? So this is the key. This is saying John New York is part of this as one of the values in the key, right? But then we go to this next one, then we have John Smith at mail.com. This is already a key. Like we already created the key from here. So then we actually just append John00 at mail.com. So then all we have to do at that point is just DFS through the emails, which is actually not that bad, right? So we could just call the scene. I like calling the scene. And so we can have a def DFS. We'll call this the email, and then we'll call it the path. And then for email in email graph, so get the email keys within the email graph. So if email not in scene, just DFS through email and path, which in this case path we can initialize as an empty array. we can say scene.add email. And also path.append email. Right? And then if and then we go through all of its neighbors after we just process the current email. So for nay in email graph of email, right? Then we say if nay not in scene, then we can DFS through the neighbor email and give it the new path, right? I think this is right. How is this? How is this for the DFS? Okay. So, okay, apparently this part is right. So then we say we also need to have step 3. We have the results, and from the result we can res.append. In this case we res append. So we have the email, right? So email, name of email. How did they write it? Yeah. Plus path, but it's sorted path. I mean, in hindsight, I wouldn't have known that, I guess. Return res. Can only concatenate string, not list to string. What? Oh. I see. Like this. This is wrong because I didn't do this initialization like it said. So I'm going to still do it, right? Because else we're just gonna have to say email graph of emails of 0. Because the thing is, like, this thing, see, it, how is this? Why did, it's saying it doesn't do anything, which I agree with, but it actually does something. But the solution is wrong if I get rid of the else, because what happens, because it doesn't consider cases where you only have one email. Huh? Where did it go? But it doesn't handle cases in the email. Like, it's just 0 though, or 1. Seems like the output is wrong. for email and email. Oh. Okay, so if I go through all the emails in, I could do email name instead, and this would work. Oh, that's true. That is true because email name has everything. That's true. Even if they have no neighbors. I don't mind that solution. I like that. I'll stick with going through the email name dictionary instead. So I guess so we go through this and then step 3 is that, right? Okay, so we have to DFS. We DFS through all the emails, basically. And we can do that through the email list. This is not easy, I'd say, but I guess once you do it, it makes sense. Oh man. Okay, cool. All right, so that's one solution. That's not even the most optimal solution. This is the DFS solution, and this is, I think, in we technically have to sort the array anyway, so it's n log k, where k I think is the length of the amount of emails you can have. So let's see, or nk log nk, or k log n. Okay, I guess nk log nk, because n is the number of accounts and then k is the max length of an account. So n times k, the total number of emails will be n times k. DFS traversal will take nk operations. It's kind of complicated. Shut up, Techno. Okay. Let's go.
Honey? Wait, what? COVID-19, my heart disease. I'm not going to wait. If it's COVID, Paxlovid.
Paxlovid is an oral treatment.
Hey everyone, welcome back. Make in like disjoint graphs, so maybe these two belong to the same energy, and actually make it more optimal. Instead of taking accounts and connecting them, we can actually do something even more bare bones, where we actually just skip to the emails themselves. We take all of the emails that belong to the same person and create disjoint sets with them. So like this could be a disjoint set, and then we could add.
The reason it works is because we use a hash map to denote basically the ID of who it belongs to. I guess that's the reason it works. I think that's the reason it works. Okay, so we use reason this works is because we go through an email name. We're saying John Smith belongs to John. John New York belongs to John, right? And we're just going through the names. And through the names, we will go through everything in the graph dictionary that we created. Where in the graph dictionary, we had a John Smith. Yeah, because we're going through every email in email name. We don't really care about the John, do we? We're basically just going through every email, right? We're just DFSing through every email. I really don't think... I mean, I guess the name is only relevant within this res append, but technically this whole problem could be done without the name, I think. The name aspect of this problem is like basically irrelevant, I think, because we just need it for the sake of identifying who this email belongs to, right? And then we create that path. So we're basically saying like this email, John Smith, right? Basically go through everything that John Smith has and we're appending it to the path. So John Smith, boom. So within the graph dictionary, find me all the neighbors in John Smith, which is John New York as well as John's 00. So then these three things would be appended to the path, right? And then we can simply just append to the results with the email name because we have the email mapping because we know exactly what email belongs to what person. And so if that's the case, we have a scene set, right? We have a visited set or a scene set in our case. And so if we've seen it already, then we don't need to look at it again. Makes sense. This makes sense. Okay, so now let's look at the more optimal solution. It's supposed to be more optimal.
Others, so we know that all these emails belong to the same person. We would run a DFS on them and do pretty much what I described earlier. I won't go super in depth into the solution because I'm not going to code it up, but I'll say that the overall time complexity of this is going to be the same as the union find solution that I'm going to show you. I think this problem is a natural union find problem, so that's what I'm going to be going with, but I'll also admit that it's not super easy to come up with. This isn't the type of problem where if you know it's union find that you can immediately solve it. It's still not easy, so I'll explain it to you now. Suppose we have a bunch of accounts, A1, A2, A3. With union find, what we want to do is find accounts with the same owners and then merge them together. Pretty much what I showed earlier. How exactly can we do this? Well, if we iterate through every single account, we're going to get a list of its emails. We want to know if an email belongs to multiple accounts. The easiest way to do that is iterate through all the emails, take each email, map it to the account index. So let's say account index. We could have also done the account name, but that wouldn't work, and you'll kind of see why. We need the account index. And then later, maybe we're going through account number 2. We're going through all of its emails, and then we find an email that we've already inserted into our hash map. This is what we're going to do. We're going to take each email, map it to the account index that it belongs to. If we ever see an email that already exists in the hash map, that must mean it belongs to multiple accounts. So we're going to take the current index that we're at, like the current account index that we're at, let's say it's equal to 2, and previously we took that same email and mapped it to maybe account index 1. So now we know that account index 1 and account index 2 belong to the same person because the email and must meet its emails. And then that wouldn't work. Account map is a list of its emails. We want to know if an email belongs to multiple accounts. The easiest way to do that is iterate through all the emails, take each email, map it to the account index. So let's say account index. We could have also done the account name, but that wouldn't work, and you'll kind of see why. We need the account index. And then later, maybe we're going through account number 2. We're going through all of its emails, and then we find an email that we've already inserted into our hash map. This is what we're going to do. We're going to take each email, map it to the account index that it belongs to. If we ever see an email that already exists in the hash map, that must mean it belongs to multiple accounts. So we're going to take the current index that we're at, like the current account index that we're at, let's say it's equal to 2, and previously we took that same email and mapped it to maybe account index 1. So now we know that account index 1 and account index 2 belong to the same person because they have an email in common. So what we're going to do is union these two accounts together in our union find data structure. Let's just assume we have that, because that's not what I really want to explain, because this problem is hard enough. Hopefully you do have a decent understanding of union find. If not, there are other videos on my channel that explain it. So by the end of doing all of this, we will have our disjoint sets. Maybe A1 and A2 belong to the same person, A3 and A4 belong to the same person. We'll have that. But now with this information, what are we going to do? Well, once again, we're going to iterate through all of the emails that we have. Now we don't care so much about the account index, though we actually are going to use the account index that we mapped each email to. But we're going to take that account index and using our union find data structure. Remember, union find has two operations: unioning two disjoint sets together, or finding the root parent, or aka like the leader of that disjoint set, because each disjoint set will have a leader. I'm drawing them like this, but in reality a disjoint set is drawn like this, where maybe A1 is the leader and A2 over here is the child. So why we want to find the leader is because for every email it belongs to a single person. We need a unique identifier for that person, and we're going to use the index of that leader account. So our find operation will give us exactly that, the index of this account. In this case, let's say it's 1. And then using this index, we want to map this email to it. So we're going to say index 1 has this list of emails, and we'll be able to do that for every single email. Every email will now be mapped to a single account. It won't have multiple accounts, it'll have a single account. That's why we're doing this find operation. We just want to have a single account that aggregates all of the emails that belong to it. And you can probably see by now, if we have that, if we have a mapping, so maybe account 1 has all of these emails, account 2 belongs to the same person, so therefore it's actually not going to have any emails. We don't even care about this anymore, but maybe account 3 is the leader of the other disjoint set and it has another set of emails. So possibly we started with 4 accounts, 1, 2, 3, 4, but now we're only left with 2 accounts because these are the actual accounts after we've merged all of the accounts. And we will make sure to sort the emails and have the name go at the beginning of the array, just like they want us to do in the output. So that's pretty much how we're going to solve this problem. If you still don't entirely understand it, this was just the intuition. Now let's actually code it up and see how it works, and then we'll talk about the time complexity as well. So I'm going to skip writing out the union find.
Skip the union find portion. Because I guess it's always the same? Like... Am I just supposed to memorize this trash? Okay, I guess for a union find, you just need to memorize that you always need to have the parent array and the rank array. And then from there, you just create the find and the union functions, which there are some optimizations to be made. It's apparently supposed to know to do some like path compression, you know, with an extra line. And also, I don't know, I think the find and the union are basically done in basically constant time.
Because it's mostly just boilerplate. This is like standard union find that you would write in any type of problem. If you know it, then you know it. We have our constructor where we're passing in the number of nodes that we have. In this case, we're going to pass in the number of accounts. So let me actually just do that right now. We're going to construct a union find instance, passing in the length of our accounts array, and I'm just going to call this UF for short. And it supports 2 operations: finding the root of a given node or value in this data structure, and we're doing path compression, which is going to
I see. So the union find, creating it on the
make
length
both
of the accounts. Okay.
of these operations basically run in constant time. And we also have the union operation, which is going to use our rank, which is aka like the size of each of our disjoint sets. Initially, each of them has a size of 1, and initially each of their parents is going to be itself. But as we union the disjoint sets together, the parents might change, so we're going to be unioning by rank. That means the set with fewer nodes is going to be the child of the set with more nodes, and then we would update the rank accordingly. So the parent is the one that's rank is going to increase. So now let's actually get into this problem, not the union find specific stuff. So we have our union find instance. What we want to do, remember, is map every single email to the account, more specifically each email to the index of the account that it belongs to. Now when we iterate through each account, which I'm gonna do like this, in Python you can enumerate, which allows you to get the index and the value at the same time. So I is the index, A is the account. Then we want to go through every email in the account. But remember, the first value of the account array is going to be the name. We want to skip that. So we're going to start at index 1, which is going to give us the emails. Now, there's two cases here. What if the email already exists in the hash map? That's one case. And the other case is if it doesn't. So the second one is the simpler case. If it doesn't exist in the hash map, let's just go ahead and add it. So email to account at this email is going to be mapped to this index. Now,
We're mapping it to the index. That's a little different than the way the DFS does it, I feel like. Because we're mapping the email. It's different. It's different because we're saying the parent email. The parent email is an array of emails. That's the DFS approach. But in the union find approach, we're saying we're mapping the email to the index of, I guess, the account. I guess account index, you could call it.
otherwise, that means this email not only belongs to this account at index I, but it also belongs to whatever index that we inserted previously. So we can get that by just taking this. I'm going to copy and paste that. So these two indices, aka these two accounts, should be merged together. They belong to the same person. They have an email in common, so they belong to the same person. We're going to take our union find data structure.
If they exist, yes, I guess if the email is already in there, then we have to union them.
And union these two together. Once all of that's done, we will have our disjoint sets. But what are we going to do with them? Well, for every single email, it should belong to a single account. So we want to create those accounts, aka those email groups. I'm going to create a default div. This is a hash map that will have a default value of a list, because what we want to do now is take each index of the account and map it to its list of emails. Now, this won't necessarily have every single account, because if multiple accounts belong to the same person, we want to merge them together. So this will be that merged set. But for every single group of accounts, we have to identify a single account that's going to basically act as the leader after we merge them together. So I'm going to iterate through our previous hash map that we created, which will give us every single email and the account index that it belongs to. I'm going to change this to be a bit shorter. I'm just going to call it E. So we can iterate through that.
So what, we iterate to do a find on all the emails?
A hash map like this, email to account.items, because we want the key and the value, which I'm getting here. So we want the leader of this account. So we're going to say union find.find I. I could be the leader itself, or it could have a different leader, but basically we want a single account that's going to act as the leader. And for our email group, we want to then map this leader and then append to it this email. So for every account, we want to get all of the emails that belong to it.
For every email.
So for every account, we want to get all of the emails that belong to it. That's basically what we're doing here. It might make sense when you see it now, but it's definitely not easy to come up with.
Doesn't even make sense to me. This is not easy. I've never dealt with union find in my life. Is this like, I feel like this reminds me of the time I took physics in college. And I thought physics was so hard. And it was. I just feel like having no pre-exposure to this stuff makes life much more difficult. But it's okay. At least I'm getting exposed to it now. Physics with me too. Yeah, like chem was like pretty easy for me. And that's because I took AP Chem in high school. But like I never went the physics route in high school. So like when I took physics in college, I was like, bro, what is happening? I would just get owned.
Now, otherwise, that means by a single account that's going to basically act as the lead.
And maybe if I see another perspective.
I will write the code and I'll walk you through it line by line so you can see exactly how to do it. And I think it should become a lot clearer. But essentially what we want to do is we want to figure out some way to take our input here, which is our list of lists, and we want to transform this into a graph. And we want to use this graph is to...
Everything is just triangles? Is that true? Dude, I feel like physics was so hard. I don't think it was just triangles though. The concepts were much more... I don't know. I feel like in the exams, I would just like think I know the answer, and then somehow it's just another answer. I'm just like, whoa, what? I thought physics was just like formulas, but like for some reason, like my formula is not working.
To do a depth first search, and essentially that way we're going to build all of...
But springs down to triangles. Interesting.
These connections, because obviously the DFS will give us all the possible, emails we can reach from an email.
I don't know.
And then, we'll need some way to look up from an email to the name. So we'll have to probably maintain some extra data structure to do that, just so we can know who the final person is. And then from there, we will do our DFSs for each of the nodes in the graph. We'll maintain a visit set, make sure that we don't get caught in the cycle, and we will eventually convert it to answer here. So that is a little bit hand wavy. Now let's go to the actual code editor. We'll write it line by line. You'll see exactly how we're going to do it. It should be really clear. This is a really simple graph problem. All you need to know is how to transform it into the graph and then how to actually do the traversal, which is just a relatively straightforward depth first search. So I'll see you in the code editor.
Oh wait, he does a depth first search solution.
Emails for that. The graph will perform our DFS. So remember, we have this email's name, and we need to basically fetch the name of the email, number of accounts that exist in our tree here, or in our graph. So basically, the number of like people here, and then we can say that k is going to equal to the max number of accounts per user. I guess the check actually max number of emails per user. Then to traverse the tree, it's going to take big O and k time. So when there's one number of accounts that exist in our tree here, or in our graph, so basically the number of like people here, and then we can say that k is going to equal to the max number of accounts per user. I guess the check actually max number of emails per user. Then to traverse the tree.
Thermodynamics. I never got that far. I didn't really need to go that far in physics, thank God. Probably would have failed that if I had to take that. If email not visited, stack email while stack. Bro, I don't understand. Okay, so in this approach, we're going through every single. Basically, we're basically doing it through a stack by DFSing. While stack.
It's going to take big O and k time. So when there's one account, it's just going to take k times. We have to basically traverse all of the emails. So to do the actual traversal, it's going to take big O and k, right? So for each email.
N of k. No, it's not n of k, but it's k log k. I see. It's n times k, but because we sort... Okay, so we could basically just say it's n k, but because we have to sort every single path, basically, it's k log k time.
Account that we have to traverse all the emails. That's why it's NK. So that's gonna be the actual like.
I failed my physics final. I forgot what I got in physics. I feel like I got like a B or something. I don't remember.
Graph traversal part. Now remember that we're sorting here.
Maybe C+. I don't remember.
So this sort operation.
Probably B, I think. Maybe C+. I'm not sure.
It's going to be okay. Well, how many times do we have to perform this sort? We have to perform this sort. Basically, n times. So the number of distinct accounts that are in the graph. So
I just remember like some of my high school friends, or not high school friends, some of my college friends. They found it so easy. I was just like, bro, it's not fair, man.
like, this John, this Mary, this John, we have to do n times log k, because we're sorting over a list of length k, which is the number of accounts the user has. So it's going to be, times n log k. So our like global time complexity is going to be, n times k times n log k. So this is going to be, the time complexity here, and that's a little bit of a weird one. So what is the space complexity? Well, the space complexity is going to be dominated entirely by our graph here. So to build, our graph, in the worst case, like we said, all of the emails are going to belong to one person. So, our graph is going to have to just store all of the accounts that were basically given to us as accounts. So in the worst case, this would be like, one key here, so it'd be like user one, and then they would have all the, emails, and just be like 1, 2, 3, all of them would belong to them, which is just going to be, in total, it's going to be n times k space, where remember, n times k. And why is it n times k? Remember, n is the number of accounts, so that means that this is going to be the number of, keys in our dictionary, and k represents the value of the emails for that user, then there's going to be n accounts, and then each account is going to have k values to it. So that's why it's n, big O, nk for the space here, which is going to be represented by a graph, which is going to dominate the space complexity here. So that is your time space complexity. Just to recap, it's going to be n times k times n log k for the actual.
The question is, am I expected to know the union find solution to this, or can I just do the DFS solution? Question mark. I got a B. Yeah, I struggled hella hard too. Will the interviewer be okay with the solution and not union find? These are the real questions to ask that I would like to know. I don't know, dude. Dude, where is Betsy here? I wish Betsy was here. I need Betsy's knowledge, insight. Oh man, I just need somebody to ask. All right, let me ask ChatGPT. Yo, ChatGPT, I'm doing the accounts merge legal question. Do you actually think it's necessary to know the union find solution, or is the DFS sufficient for a meta onsite?
That's a really good question. Honestly, for something like a meta onsite, either DFS or BFS or a union find approach is generally acceptable. The main goal is to show that you can solve the problem efficiently and that you understand how to handle connected components. DFS or BFS is often a bit more intuitive and is perfectly fine for most interviews. If you're comfortable with it and can explain it well, that's great. Union find is just another tool in the toolbox. It can be a bit more efficient in some cases, especially for large data sets, but it's not always a must. If you already have a working DFS solution and you can reason about its complexity, you're in good shape. So don't stress too much about switching unless you just want to practice both.
Then do you think it's worth my time to memorize a union find template for these types of problems, or is it just not worth my time and just, be satisfied with knowing the DFS solution?
I'd say it really depends on how comfortable you feel with the concepts you already know and how much extra time you have. If you're already feeling solid with DFS and you're managing to solve these problems confidently, you're probably fine sticking with that. It's often better to deeply understand one approach than to half memorize another. That said, if you do have a bit of extra time and curiosity, learning the union find pattern can be a nice addition to your toolkit. It can be handy for certain types of graph problems, and it's not too hard to pick up once you see it a couple of times. But it's definitely not mandatory if you're already confident with DFS. In short, focus on what you're comfortable with first. If you have extra bandwidth, union find can be a nice bonus skill.
That's true. That's true. Okay then. Yo, Techno, do you know union find? Do you know how to do union find? Okay, maybe I just don't do it through a union find. So I feel like union find makes, I don't know if it makes that much sense, if I'm being honest. I feel like union find is not that intuitive. DFS, I feel like is pretty intuitive. It makes sense, I mean, to be fair, whether or not this is intuitive or not, I don't know. I've done 2 questions. do you understand it though? I mean, conceptually, it's not like that difficult, I guess, but the boilerplate to set it up, I feel like is like, I don't know. Do I really have to memorize that? I don't know. Let's see. The email keys within the email graph. I mean, this solution makes sense, but then let's see if this...
And that way we can just, save space for the other ones. Okay, cool. So, name. And the reason that we need to do this is to build our graph. And for our graph, we're going to need to maintain a mapping, which is going to be the key as the email. And the value is going to be all of the emails that it's connected to. That way, for every email, we know all the possible edges we have in our graph, and we can do our traversal that way. So let's set up this data structure. So we're going to say graph is going to be equal to collections.default dict. And here we're going to use a set. And the reason we want to use a set is because there's going to be a lot of duplicates in this, in the list of items, because obviously there's going to be emails that are duplicated. So we don't want to have to basically traverse things that we've already done. We want to use a set to maintain a unique collection of emails that we can reach from a given email. So that's why we're using a set here as the value for our dictionary. And what we're also going to need, and you'll see why we need this later, is going to be actually a map which takes an email and maps it to the name. And the reason that we need to do this is remember that we need to return our solution as the first element should be the name. So we need to be able to go from an email and figure out the name so that we can return it in this correct output that it wants. It's really strange, it needs to be sorted as well. But that's what the problem asks for. So that's why we need this extra data structure. That whatever node we kick off the DFS from, we need to find the name of that person. Remember the nodes in our graph are going to be emails, so we need to go from email to name. So that's why we need a map like that. So we're going to say email to name is going to equal to just an empty dictionary. So now we actually need to build a graph, and we're going to get the data out of our accounts here, which remember is in this form of a name and then all the emails for that one person. We know that these emails are connected to each other. So we're going to say for count in accounts, and remember that the first element in this accounts list is always going to be the name. So we're going to say name equals account of 0, and we're going to say okay, so now we need to go to the email. So what we want to do is we want to now build the shutter, and instead of doing the first node and then from the first node you can go in, just going to cut things down, make it actually a little bit simpler. And it's just going to blow up the actual space that we need here. So we're going to keep it simple and just go to the other ones. So we're going to say graph of each particular email. We're going to add the first to it to every other single node in the graph for this to be the reverse connection, and that way we can just save space.
So he uses a set instead. Oh, that's true. That is true. We don't need to do it as a list. We could do it as a set.
This particular email, what names it corresponds to. So remember, all the emails in this account 1 are going to be the same person. So it's like John Smith, John New York, are all going to be of this guy John.
Because if you add another duplicate email, then it technically does like it's duplicating.
Just set them equal to whatever the name was. Cool. So now we built our graph, and what we need to do now is actually build our results here. So we need to go through the graph, perform our DFS, and we need to build the result. So the result is a list of lists here. So we need to define that data structure for it. So we're going to say res, just an empty list. And remember that we're doing a tree traversal here, sorry, graph traversal. So we do need some sort of visited set to make sure we don't get caught in an infinite cycle. Because remember that all the emails are linked back to this account 1, so it's possible to get into an infinite loop if you don't look for it. So we're going to say visited, so it's just going to be an empty set, keep track of where we've been. Now we need to go through our graph. So we're going to say for email in graph. So this email obviously represents like a node in the graph. And then we're going to try to go to all its connections in depth first search manner in order to basically just find all the connections for that given email. And then we're going to add things to the set as we go along. So we're going to say if this current email hasn't been visited before, then we need to do some work here. So we're going to say if email not in visited, visited. What we need to do is we need to set up our DFS, and I'm going to do it iteratively instead of writing a recursive function. So I'm just going to use a stack here. So I'm going to say stack and I'm going to put email in there because that's what we need to process. And then I'm going to add this email to my visit set to make sure that I don't get caught in that infinite loop. Now what I need to do is I need to build out all of the emails that I can actually reach from this email. So I'm going to need to keep track of that. So I'm going to say local res, which is just going to be all the emails I can reach from this email. It's just going to be an empty list. And what I want to do now is actually perform my depth first search. So I'm going to say while stack. What I want to do is I want to get the node out. So it's going to be node equals stack.pop. So I'm going to get my next thing to process. And okay, so that means that this node is accessible from this email, so I need to add it to my result because I've seen it along the path. So I'm going to say local res.append the node, and what I'm going to do now is remember that it's a graph, so I need to go to all of the nodes that I can from this particular node. So I need to basically traverse all the edges, and then from each of the nodes that I can reach, then I need to go into their children and on and on and on. So I'm going to say for edge in graph of node. I'm going to say if that node hasn't already been visited, then I want to explore it. Obviously, if it hasn't been visited, we'll get caught in an infinite loop. We don't want that. So we're going to say if edge.
It makes sense. I gotta move on though. I think generally I think it makes sense. Like I got it to work. I have a solution that works. Kruskal algo. Oh my god, you know what? You just naming a random person's name of an algo reminded me of there's apparently some algorithm called Mancasters algorithm for specifically for valid parentheses type questions, and it's bro, why are we being tested on this stuff? It's so cringe. I don't understand how we're supposed to know this stuff. It's really? I mean, maybe if they just expect us to mention it, but to actually implement it is There's no way. There's no way. It's like, what is this stuff? What are they expecting out of us? It's so sweaty. It's so sweaty. Okay, let me keep track of the questions that I'm doing. I feel like I'm skipping. I'm not logging all my progress. Where did we end off? Threesome, then remove dupes. Remove dupes. Longest palindromic substring. I have done this, but I haven't marked it. Longest palindromic substring. I think I read this one. This one's a medium. Oh shoot. That's the wrong color. This question, what's the algo? Oh, you start from the center. Start from center, then handle even and odd case. This is a DP question? Is it? Oh, wait. Are you talking about valid palindrome 3? What's up, Bleh? Good to see you. Good to see you. The current one? What, this one? Longest palindromic? Is it really? That is cringe. I mean, you don't have to solve it with DP though. Oh, this one has the Manicur's algorithm, the cringe algorithm. Yo. There's no way. There's no way. There's no way. Like, bro. Apparently the algorithm is to like you insert some sort of random special character in between every letter, and then you do some like shenanigans with the pointers and stuff depending. I don't know, bro. It is O of n time though, which is way more efficient than n squared. But like, look at this. Yes, imagine not getting the job because you didn't know Manicur's algorithm. Like, bro, I just got this today. Oh my god, bro. There's no way. The interviewer needs to be brain dead to think about asking to optimize beyond DP. Next, the interviewers be like, optimize it. Oh, one. Honestly, I think I'm just gonna gamble. I won't be asked that. My friend at Google used to ask this question, but eventually it was banned because people online leaked. Thank God someone did. Note the Manchester. It's not even called Manchester. Why do you say Manchester? Out of scope. Meg, hold my beer. These guys are too funny. Yeah, I thought it was like Manchester's in the beginning too. Whoever got that question first, tough luck. That's what I'm saying. Like, I don't know. Even as an interviewer, unpopular opinion, Manicur's algorithm is a solved problem and not hard to learn. You should probably know that if you expect to pay you $250K to update their React app a couple times a year, the bar is not that high. Now repeat that attitude with 100 other similar algos only found in PhD papers and expect them to write them out flawlessly in 20... Exactly. Wait, this person wrote this 6 hours ago. Like, I don't understand what's going through the interviewer's head to like actually Maneker's algorithm is greater than Maneker United. Dude, the fact that like even Neat Code, I feel like all the videos that talk about this stuff don't test for this. I don't know. I genuinely feel like if I get an interviewer that just like wants me to, I just pray that they allow me to just mention it. I saw that question, got pissed, and never solved it. I mean, as long as you're not doing the most optimal solution, it's not that bad. But if you're trying to do this like with that algorithm, I'm not trying to spend like a couple days just to figure out what that algorithm is. It's like so stupid. Just mention Maneker's algo is more efficient. Oh man, I'll just mention it, but that's it. So that's that. Contains duplicates too. Dude, if I studied all this time just to get someone to expect me to answer with Maneker's algorithm, I might lose it. What a waste of my life. What a waste of my time. It's like, yeah, that's what I'm saying. Like, why? I mean, I get it's like you're being tested on algorithms and data structures, but like, why are you why would an interviewer test you on something so specific that's like, does it really matter that you know that algorithm or not? It's like, I feel like leak code is nice in the sense that like there are a lot of common patterns, but like to go as far as in saying like okay, you know what, I'll say this: if the interviewer doesn't expect you to implement it, that's fine. I think if the interviewer expects you to just mention it, that's fine. But if they expect you to code it from start to finish, that is absurd. I think that's absurd. Am I a new grad? No, I work. I have been working. I've been working, I think, as a software engineer for almost a decade now. Has it been almost a decade now? Maybe it's been almost a decade, but that's what I'm saying. Like, at my work, I don't care about Maneker's algorithm. I don't know. I don't think a lot of my job deals with parentheses. Like, bro, it's the most useless thing in the world. But like, if an interviewer expects you to study and memorize that, that's stupid. You look like a college student. Well, that's flattering, but I'm well out of college. I graduated in 2016. Actually, almost 10 years ago. I am hella old. Isn't that crazy? Graduated in 2016, man. It's a long ass time ago. I joined in college in 2019. I started in 2012. What company I work at? I'm not gonna say, but my company did get bought out by AMD. So if you want to do your research, I guess you could figure it out. I graduate this year. I will graduate in 27. Jesus Christ. You guys are so young. I don't know if I feel like my brain is just slower to absorb information. I'm not sure. But, I mean, I still do feel like I'm learning. I don't know if the pace at which I was learning is slower, though. Hard to say. I feel like I still learn decently. Started college in 2023. Damn, you're also hella young. Guys are all in your mid 20s, young 20s. Must be nice. Must be nice. You're gonna pursue a master's? You do look younger than you did like 5-6 years ago. Wait. What do you mean I look younger than I did 5-6 years ago? How do you know what I looked like 5-6 years ago? Am I doing for a job? Yeah. I have a meta on site next month, so I'm legit just lasered in on trying to grind it. So contains dupes. What was this solution? I vibe to your music? Oh shoot, that's crazy. I'm surprised you're here. You did age reverse? No, I didn't. What do you mean? Maybe it's the hair. I don't know. I feel like I look the same, if not older. Anyways. So this question... Oh, it's a sliding window. Sure. Sliding window. I guess once I speed run through all these questions again, I will need to instantly recognize what kind of pattern this is. Pineapple Lee. Yeah, I did have longer hair back then, which probably made me look a little bit older too. But long hair is so annoying to manage though. It takes so long to dry, requires more product. It's just so annoying. Gets tangled. It's harder to make it look good. It's just not worth it. Contains dupes too. Continuous subarray sum. Continuous subarray sum. I don't think I marked this question. There's a lot I didn't write down. My Korean, yes. Good thing I'm bald. Come on, chat. Once you guys get to my age, you guys would be jealous to have my head of hair. Trust. I feel like I have a bunch of friends that are like actually like balding. I feel like I'm doing pretty good for my age. I passed the genetics test somehow, but it's all just RNG. It's something you're born with. It's not something you can really control. This is colored. This. What is happening? What do new grads do after work? Life seems unstructured. I mean, that's up to you, I guess. And it also depends on the work you do. But for most people, if you just end up in like a cubicle and you don't really have like many events going on in your work, then life, I've heard some people get some, I don't know if there's like a term for it, but I think some people get kind of like depressed or like shocked at the sudden like change. Because I will say like for most people, the amount of people you interact with in college will like basically be the peak for most. That exposure to people and interaction, I would say like heavily goes down unless like you're actively seeking like after it. But low-key, I was different though. I don't really like interacting with people. I like being like doing my own thing. So like I would just I basically just, you know, did my own thing, and I'm fine with that. But some people are like extroverts and stuff like that, so I can't really relate. Joining a gym or a local recreational sports club? Yeah, to be honest, like, I think that's what I would do if I was like more normie. But I'm like a gamer, so I feel like I would just prefer to hang out over like Discord or something. But yeah, I think if I was like looking or seeking like a community that I really wanted to, I guess, fill that void, I'd probably do something like that. I won't bald. I don't know, man. You never know. Honestly, as long as your parents are not balding or their head of hair seems like pretty good, then I think genetically you should be pretty good with your lottery. It's so easy to hermit and lose connections. Yeah. Yeah. I feel like I'm very like antisocial in some ways because I think like it's a lot of work to, I don't know, sometimes people are annoying and my patience for people usually grows thin. When people are like super like low IQ. But that's why I usually just stay to myself, because I'm just like, you know what? If I don't have to interact with people, I don't have to deal with brain dead people. So I'll just live in my shell and be at peace. And I've been doing that at work lately, and it's been nice. Do I do skincare? I do. I actually got like on a new routine. I had a facial actually somewhat recently, and the person that helped me out gave me some new routine to do. So I guess I changed up my routine. Pretty depressing at the moment. I'm not too social, but I'm trying to improve. A bit of gym. I mean, I will also say like, well, I don't know. I don't know how it is for some people, but I will say like, you're gonna have to be okay with, you know, people coming and going. Like that is something that will you can never control. I mean, yes, there are those cases where it's like there's some people that are like, you know, friends forever, biffles for life, whatever. But I mean, the reality is like for 99% of people, 98% of people, like people are gonna just come and go, even if they were the closest people in your life. Like people will get married, people are gonna move because of jobs, like everything changes. And you know, technically you only do have yourself. Like you are, like, as long as you're alive, like you are the only constant in your life, right, that you can control. Everything else is kind of like, you know, it's not in your control. So I would say like the most important thing is like you got to be grounded in yourself. That's the most important thing. I'm still learning to get used to that. Yeah, I mean, I can understand how it's tough for people. I think one thing that helps, I think at least for me, is that like I think I remember hearing about this in some way or at some point in my life. You basically just don't want to put your eggs all in one basket, right? Like, of course you've heard that saying before, but like I would say it goes for the same as like friendships. Like, of course I would say friendships are important, but if like friendships is all that like kind of maintains you in terms of your happiness, I would say like low-key that could be dangerous, because once that's gone, then it's like, what else do you have left, right? Like for me, it's like, yeah, I have stocks, I have, you know, my place, I have, you know, my friends, my job, whatever. I have a bunch of things that kind of like can, you know, give me satisfaction or not. But like if one of those pillars go down, it's not like, it's not the end of the world, right? It's like if a friend goes away, then it's like, oh, okay, yeah, that sucks, but like I do have other things in my life that I have going for me, so that's okay too, right? Tips for clear skin. I feel like it's honestly genetic in some cases, and I think eating healthy helps. And also, you know, I guess if you, I mean, to be honest, like I feel like I don't really take that great care of my skin. I mean, I do take care of it, you know, when I can. I used to take care of it a lot more, I feel like, but make sure to wear sunscreen, because the sun is like cancer. for your face. Eggs? Yes, I said eggs. Life lessons? Yeah. But what are the point of life lessons? Because, you know, even if I were to hear these things back in the day, even at your ages, you guys probably won't even listen to the things I say. Because, like, I was watching this interview from, like, a very smart engineer, and he was, like, saying... I would say that advice to my old me, but I'm pretty sure, like, I think that guy was saying, like, you wouldn't listen to, you know, what the older you has to say, because you're you know, you're too stubborn, you're too young, and you want to just do your own thing. That's like, it's always the things, I guess, like in hindsight, that I don't know. I think most people won't ever take advice. I have some small acne scars. I'm trying to get rid of that. It's difficult. I mean, to be honest, if it's like bad, I know some people, I think, go to like clinics and stuff to try to get it like fixed. Really case by case though. I would say like some people have, you know, just worse RNG, and you have to just maintain more or do more. So hash map with the remainder. Oh, I remember this problem. Hash map with remainder. I don't know. These questions I don't even remember doing, but hopefully I'll remember. Let's see. Valid palindrome. Alright, valid palindrome 3. I think we are... Oh wait, no, I still have to do accounts merge. Tretinoin? I've never heard of that. I've been hearing, or I don't know, I've heard of people like taking stuff with like hair loss stuff. I've never done that yet, and I don't know if I plan on doing it. I've heard of people taking things like minoxidil and like some other one, I forget. I don't know, dude. I don't know, dude. Acne takes a good minute to fix. I feel like my acne was worse in high school, but I think it was maybe also partially due to my hairstyle. I mean, also probably just, you know, puberty and stuff. But acne, I feel like I always had like a decent amount on my forehead, but like my hairstyle back then, like my head covered my forehead, and I feel like the oils just like it thrived under my hair. It was like a perfect breeding ground. But now I just like do a middle part, so it's like, I don't know. I think also I'm just older now, so I think my hormones aren't going crazy anymore. I'm like normal again. I usually don't break out, but I think breakout is also partially like, I don't know, could be many things, but I'll say sometimes it's just genetics. GG. DFS with union find possibility. Maybe mention it or learn it if you have time. Getting a girlfriend boils down to confidence and socialness, or things like skin and other stuff. No, I don't think looks are everything, but I mean, I think it also depends, like, it depends like what the standards are. Like, for example, if like, you know, unfortunately, like, we are very, I don't know, some people are very shallow people, so it's like, you know, if you're like a 5 and you're like trying to shoot for like a 8 or 9, it's like, gotta be realistic. But it's like, if it's somebody around the same, like, you know, same, then it's like, I feel there's plenty of people that will look past just the looks. To be honest, I don't even know if it's that like. I think also the older you get, I think the people will start to like mature more. I think in college people are still very like shallow, or you know, don't really care that much about their future. It's a very early stage in life though, I feel, college. But I don't know, you never know. I mean, if you don't find one in college, you don't need to find one in college, you could always find one later too. But I will say, I think confidence goes a long way. But still, that's not to say, like, I think, you know, oh, I don't know. You know, I don't think, I mean, I've seen, you know, I will say, I've seen some guys that don't look that great, and they're with a pretty girl. So it's like, when I see those scenarios, I'm just like, God damn, like, I mean, I will say, I mean, let's be honest. Like, if you also have like a lot of money, I think some girls find that attractive, you know? Like, if you don't got the looks, then you basically just find other ways to carry like your overall score, right? Yeah. But I would say, like, it also depends on like who you want to go for. Like, are you really trying to go for somebody that really cares about that much, like in terms of money? So you got to be funny. That's true. Yeah, you got to be funny. I feel like being funny is good too. If you're just like very stale or dull, it's like, bruh. It's like, I don't know. Like for me, I feel like it's easy to talk to people in a way, I think, if I want to try. But if I'm not trying, then I won't try. Usually I don't try. I mean, not anymore these days. And not funny looking. All right. It's a good thing I unmodded you a long time ago. You deserve to be a pleb. With that comment. Is that a ring on your finger? Yeah, but it's on my right hand. I mean, it's just a ring I got from like a old college group I was in. And I haven't taken it off since. Just be goofy and sincere. Yeah, I mean, it really depends on the person. But yes, I will say, like, you know, don't take yourself too seriously. I think that's important. Make me mod. I'll think about it. If I get my meta offer, I'll make you mod. Solve a question, please. Oh, you're right. I'm trolling right now. I've been distracted. Okay, sorry. Okay, now we're actually on this question, valid palindrome 3, which I was kind of solving and then like stopped. So valid palindrome 3. All right, let's lock in. Let's get back to locking in real quick. Light red. Is it the light red or this one? I think it's this one. Okay. I know the answer to this. This is basically like valid palindrome. It's DFS with memoization. Thank you, Silent. Appreciate you. Take care. Yeah, why is techno being nice all of a sudden? All right, so the thing is about this problem. Okay, so valid palindrome 3. So in valid palindrome 3, basically the intuition behind this one is, okay, so the question is you're given a string and K, right? Return true if S is a K palindrome and a string is K palindrome if it can be transformed into a palindrome by removing at most K characters from it. So basically what it's saying is as long as K is greater than 0, then that means we can remove a character, right? So remove a char. So we have A, B, C, D, E, C, A, right? And basically with palindromes, I would say you either start from the middle or the outer, right? But in this case, I think you would want to start from the outer. So we'll have our left and right pointers, and A is good. So we move our left pointer and our right pointer in. And in this case, they're not equal, right? So when they're not equal, we have two choices to make, right? We either move our left pointer to the right or we move our right pointer to the left, right? And in this case, actually moving our left pointer to the right is correct. But in code, we actually don't know that. So this is, I guess, where the DFS comes in, because for every incorrect left and right character, we need to DFS moving the left pointer to the right or the right pointer to the left. And apparently, to make this a little more optimal, we're going to handle any repeated work with memoization. So if at any point we've seen a similar string, I guess, we need to, who's that? Sub J. So at any point we need to memoize the solution, right? So this is like the general template I had, and the thing is, I don't think this is exactly right so far. I can also create a new function, right? That will just check like, is palindrome given an S, an L, and an R. Well, just a string, right? I think we can just give it a string. And also we're gonna have to give this a self because we're declaring a class or a function outside of the function. And so, you know, like classic palindromes usually go like this, and like the best -1 while is less than R. If S of L is not equal to S of R, then we're going to return false. And then we're going to move our left pointer to the right, or our pointer to the left. And we can return true by the end of all of this. I believe this is like the basic, just basic palindrome type of function. This is easy. So then the thing about this part is that while we do this, we're going to need to, we need to, I guess, recursively is recursive, I guess. I don't know if that's intuitive. We have to recursively call this function. We have to recursively call the function for every single, well, hold on. Let me see if Manicur's algorithm can be applied to this one too. No, it can't. Not this one. If k is greater than 0. So if k is greater than 0, we decrement k. But at the same time, we just DFS. We can also we need to memoize stuff. So I guess string and then bool. I think that's the logic. Okay. Do I give up? Think if I want to give up. I don't know how I can memorize within a while loop though. I just don't know how I can memorize within a while loop. I mean, I think also in here we can just say if s in memo return memo of s, right? I think we can just do that. I think. And then we basically just DFS. We're basically saying we do self.is palindrome of s from L plus 1 comma R to R plus 1. And I think we can just return. Actually, I don't even know if we need this. And or self.is palindrome s of L or R. R. I think that's right. I don't even know. I don't think this makes sense. I don't know what I'm doing. I'm lost now. I don't know. I feel like after a certain point, I just don't know what I'm doing. And I don't understand why.
I need a trunk for all this.
Hello, and welcome back to the cracking phase. Just going to tell memoize our solution because, as you can see, now that we're calling it recursively, there's going to be a lot of duplicated work. So, very high-level algorithm, we're going to have two pointers, left and right. Left is going to be at index 0, and right is going to be the end of the string. And we're going to go towards each other and compare characters. So if the characters don't match, then we need to remove, so let's see, no match. This implies that remove the left or the right character, and then call our function recursively. To basically see whether or not removing the left would create a palindrome, or removing the right would create a palindrome. And if so, then we're okay. Obviously, we're going to have some duplicated work here, so we're going to use a memo dictionary to store whether or not we can form palindrome. And the way that we're actually going to memorize this is we're going to use a tuple. And what the tuple is representing is going to be the current I position, or let's just call it the left position.
Oh, come on. How am I supposed to know that?
The current left position, the current right position. And unfortunately, this isn't good enough. We actually need a third variable here, and we need k. And k is going to represent how many deletions we have left. Because we could have LR with only one deletion left. This is actually not the same as left right with two deletions left. Because obviously, maybe you need to get rid of two characters to make it a palindrome, and what about with one? So we need to store the left pointer, the right pointer, and k to get this.
How am I supposed to know I need to memorize this? Is this because of the K?
No, that is the general algorithm. Again, pretty simple. It follows the pattern of how we solve most palindrome ones. We just need to basically call things recursively and use memo here to speed it up because otherwise they won't be accepted. So let's wipe all this away and go to the code editor and type it up. I promise you it's actually quite simple. It's just getting the solution that's a little bit tricky, but we now have the intuition. Let's code it up. Okay, we'll see where we need it. Okay, now we can actually syndrome check. We're going to say if self.string, and we'll assign string in a second. If self.string of I is not equal to self.string of j, then it's not a palindrome, and we're going to return false. Otherwise, as you know, we move I up by 1 and j down by 1. If the while loop breaks and we have to return false, then we simply return true. So we'll need this in our code, and you'll see where we need it. Okay, now we can actually code it up. The first thing we want to do is...
Well, okay. I guess I get rid of that logic I wrote. I guess I get rid of this here. And also, he passes in R and S. Okay, so if that's the case... That's weird. Okay, but let's find out why.
If k equals 0, that means that we're not allowed any deletions, which means that our string is only a valid palindrome if in its current form it's a palindrome. So this is the first time we're going to use our helper function. So we're going to say if not k, so if we don't have any deletions, we're going to say return self.is palindrome. And we are... we need to assign our string first. So we're going to say self.string equals s. Okay, so self.is palindrome. We're going to pass in, obviously we want to start at the 0th index, and we want to start the right pointer at the length of s minus 1. So, you know, obviously if we don't have any deletions, we're just going to check is it a palindrome or not, and we're done. Okay.
If k is equal to 0, then yes, we can just check if the whole thing, yeah.
Now we need to actually do some work here. So what we want to do is we want to find our memo dict, which is going to basically store...
I got approached by Google Hires for SD2 role. I turned it down. Wow, why would you reject it? I don't understand. I don't think I don't. I mean, why does it matter if you only have 1.5 years of work? Like, why does that matter? People get it. So like, that logic makes no sense to me. Yeah, but there's people that intern at Google with no experience at all, or even get a full-time experience or a full-time job with no prior work experience. Like, that logic makes no sense to me. Why should you only be allowed to work at a company once you've worked a certain amount of years? I feel like every job is just you learn as you go. Every company uses different tech anyways. Like, especially the big tech companies, they all use their own internal stack usually. Depends on the project, of course, but they all have their own internal tools. Like, it's like, bro, there's no amount of work experience is gonna prepare you for that. You know what I mean?
All of our intermediate results, so we can look them up and not have to replicate ourselves on the logic front. Or sorry, on the computation.
They turned him down. I don't know why you would turn it down. I don't understand. I mean, unless you're getting paid more at some other company, then sure, I guess. But if it was more money and you turned it down, it's like, that don't make sense to me. Lack of experience, like, I don't understand that logic. That makes no sense to me. I don't know. That to me, that just sounds. If I'm being honest, you ask for honesty. I think that's just stupid. Wait, what? The interviewer turned him down? I don't understand. What do you mean? Like, I mean, lack of experience. I don't understand. I don't understand your question. I don't understand why you're bringing up your friend. I thought this question was for you.
So let's define our helper function, and this is going to take a current position I, which is the left pointer, our current position j, which is the right pointer, and k, which represents the amount of deletions we have left.
He literally told him he did good, but his SDE2, they need people with 2+ years of experience. I don't understand what you're saying. You're telling me two different stories now. Your first message says you turned it down, and then now you're telling me your friend didn't make it because he didn't have an experience. Like, why does your friend even matter in this story? That wasn't even your initial question, no? Am I like not understanding?
First thing we want to do is actually check, have we seen this combination before? So we're going to say if I.
Worst case scenario, you get turned down later in the interview process. That's what I'm saying. That's why I'm saying if I read the first story correctly, I feel like that's just stupid to turn it down. Because the process takes a long time. Yeah, but who cares? I mean, you could still technically just say yes and still like back out eventually. Like, what do you're not going to get penalized for that.
J and K are in a memo, then we just want to return whatever is already cached. So we're going to return memo of I, J, K. Okay, so that is if the cache is populated. Now,
all right, I'm not locked in.
And we want to start the right pointer at the length of s minus 1 or not, and some work here. So what we want to do is we want to find our memo dict, which is going to basically to replicate ourselves, our helper function, and this is going to take a current position I, which is the left pointer, our current position j, which is the right pointer, and k, which represents the amount of deletions we have left. First thing we want to do is actually check, have we seen this combination before? So we're going to say if I, j, and k are in a memo, then we just want to return whatever is already cached. So we're going to return memo of I, j, k. Okay. So that is if the cache is populated. Now there's two other cases we need to do. The first case is if k actually equals 0, in which case we have no more deletions left, which means we have to basically check, is the string from I until j, is that a palindrome? And then we'll basically return that. So we're going to say else if, not k. So again, similar to what we had in the beginning, if k equals 0 at this point, because we've already used our deletions, then whatever's left needs to be a palindrome as it is. Otherwise, it's not a palindrome because we can't use it. So we're going to say memo of I, j, k is going to equal to self.is palindrome from I until j.
Stupid decision. I should have tried. I don't understand. I just don't understand. Like, I don't know. That doesn't even make sense to me. Why would you even do the interview in the first place if you were just gonna reject it if you got accepted anyways? Like, who thinks like that? I can't understand that. Like, why would you waste your time? I don't even know. I mean, I'm assuming you have to prepare for this interview. Like, why would you waste your time to study for it and then just say no at the end? It makes no sense to me. What's the point? Why are you even doing anything? Like, why are you like forcing yourself to be hard stuck? I don't understand. The logic makes no sense to me. I don't understand. I really don't. Who said no? Oh, wait. Oh, I see. Okay, I thought you meant you got an offer and you turned it down. But you're telling me you just said you got approached to get in the interview process. Is that what you meant?
So pretty simple here. Otherwise, what we're going to do is we need to actually compute whether the rest of the string is a palindrome, while also taking into account that we have some deletions left. So at this point, we verified.
I see. No, why would you say no? That's such a bad decision. You have nothing to lose. You only have more to gain, right? Like, it's a good learning experience. That process would have like taught you things, what you're lacking in. Like, bro, I would say it's not even easy, I feel like, for most people to get that opportunity in the first place. So it's like, damn, bro. I feel like you just low-key just missed a nice opportunity there.
That we haven't already done this, so we need to process it. K is not 0, which means that
Hazelnut or vanilla or caramel? Hazelnut. Hazelnut is solid though. I will give hazelnut its credit. Caramel, vanilla, I don't know. Vanilla coffee? I don't know if I've tried vanilla coffee. I don't know if I've tried caramel coffee either. Maybe I have. I don't know. They all sound pretty good to me. I don't drink coffee, so coffee's not good for you.
need to like continue further. So we're gonna say while I 0 within J, we're gonna say if the two characters, so if self.string of I does not equal to self.string of J, we have a divergence, right? And remember back to the example where we talked about it, you can either delete the character at I and check whether it would be a palindrome, similar to how we did in valid palindrome 2, or you can delete the character at J and check whether doing that would make a palindrome. So we need to actually do both. So whether or not you can form a valid palindrome from I to J with K removals will actually equal what? So we'll say self.memo, sorry, it's not self.memo, it's just memo of I, J, K is going to equal what? So we're gonna call the helper function recursively, and let's remove the left side first. So we're gonna say I plus 1, so we're gonna chop the left, we're gonna pass J because J still needs to be checked, we don't get rid of that, and now we've used
Lack of confidence does this to you? Damn. I got a lot of time. Yeah, it's true. You got a lot of time. Just make sure to, I feel like, I mean, if there's anything I would tell you, and you'll probably thank me for this in the future, like, dude, just try things and fail. Like, I feel like a lot of people should be living life that way. 'Cause like, what you have done is like, you just chose to do nothing about it, which is I feel like a lot of cases the worst thing you could do for yourself. Because the thing is, like, if you choose to do something about it, then you can always look back and say, at least I tried and gave it my best shot, right? But then I know there's people that will look back and be like, damn,
-1. So we're gonna say
I could have done something about it, and it's like I regret not doing anything about it. Like, I'm sure there's tons of people like that. It's like, don't ever be that person. Just be the person that's just willing to fail and try things, and you learn as you go. That's it. That's how I feel like most people should be living life. Gotta drink something while driving. What the? You're gonna become dependent on coffee? It's GG. I will never be that guy that I grow old and I'll be like, need my morning coffee. Never. I'll never be that guy.
it's equal to this, or helper of, so the I stays the same. Now j needs to get moved down by 1, and obviously k is still decremented. So either this will return true, or this will return true, or they'll both return false. So depending on the outcome of this, right, if this one's true, this one's false, because we have the or here, then this is a palindrome. So this is how we're going to assign it. It's either if we're moving the left side, we make a palindrome, or moving the right side, we make a palindrome. This is what we return at this point. Now,
I mean, this makes sense to write in hindsight, but it's just like, how would I ever come up with this, like, if I have never seen it before? Like, how am I supposed to know to come up with a helper function? I don't understand.
now what we want to do is, because
You should have streamed the wild a week back. I mean, I did stream a week, or I have streamed a lot before too, but I haven't streamed studying. The studying is recent. The 4 a.m. coffee hits different. Oh man. I mean, I could see that. I could see that.
sorry, we want to essentially, oh, now that we've seen, sorry, there's a divergence here, we'll have called this recursively, so we can simply just return this, right? Because we don't need to process anymore, we'll already have done it in the child at this point. So we can simply just return memo of I, j, and k here, because the rest of the processing for this while loop will actually happen inside.
Return memo of IJK, because memo of IJK is just a boolean, I think, for the value. Yeah. But it's just a sub problem, I guess. Like, you keep going. You keep going until the memo is 0.
Of the helper.
Or the k is 0. If k is 0, then you evaluate whether or not it's a palindrome.
Function, so we actually don't need to go.
Yo, Techno, do you feel like you're good at recursion or no? I feel like my recursion is so ass. I feel like recursion is so hard. I just try to make a decision tree and then look at the base case. I did a lot of trees. Maybe I just need to do more trees, I guess.
Go any further here. Otherwise, if they continue to match, then we just need to move the characters. So we're going to move the left pointer up and the right pointer up. So I gets incremented by 1, j gets incremented by 1.
So I guess the reason of when you create helper functions is when the original function doesn't have the inputs you need for every recursive call. I think that's the reason why you have a helper for any DFS type of case. That is, I think, the intuition behind it. Yeah. Now, so I guess this is the base case, right? If we have, well, there's several base cases. One base case is it's already in the memo. So if it's in the memo, just return the memo. The other base case is if k is 0, then the memo, then you insert it into the memo. So basically k equals 0 is a base case. Because then we can just return, is that a palindrome or not? Right? I see. And we're recursively doing that for every either left choice or right choice. Cam? What do you mean, Cam? What happened to the cam? There's nothing wrong with the cam. Oh, it's blurry? Oh.
At this point, if the while loop doesn't break, that means that we actually found a palindrome here. So what we're going to do is we're going to return, oh, sorry, not we're going to return. We're going to say memo of I, J, K is actually equal to true. So basically, we can form a valid palindrome here from I to J with K removals. So basically, if this while loop never breaks. The last thing we need to do is remember we need to actually return our memo here because we didn't do it earlier and we haven't done it yet for this case. The only time we've done it is actually if we found a palindrome up here.
Dude, even like the returns I feel like are so confusing to me. Like, I don't know which return goes to what. Like when what triggers. Do you feel like that's intuitive techno or no? Like, I don't know, dude. I feel like the returns can be so confusing to me.
Or we just did the processing up here, so we
if we can connect. I mean, I'm gonna be honest. I don't do connects like that. It's a little too parasocial for me. I'm not trying to say there's like anything wrong with it. I just I usually just keep a boundary with viewers. I will say, like, if you really want to like reach me offline, you could always try to just join my Discord. I do have a Discord server. And like you could always just like post in like one of the channels or like the relevant channels, and I could try to answer it offline if that works. That's probably like the best way. I can't really do like DMs and stuff like that. Who is bro talking to? I'm talking to YouTube. Go. All right. I love parasocial relationships. They skydiving together is so much fun. I haven't heard that one before.
don't need to actually go through it again. So what we need to do now is just return.
Is a 3D palindrome? I'm on Twitch, by the way, Bleh, if you want to join on Twitch.
Palindrome here. J gets incremented by 1. At this point, if the while loop doesn't break,
I don't know if you use Twitch, by the way.
That means that we actually found a palindrome here. So what we're going to do is we're going to return.
Is this really a 3D palindrome? Or not 3D palindrome. Is it really 3D DP? How do you know it's 3D? Like, what makes it 3D?
We're going to say memo of I, J, K is actually equal to true. So basically, we can form a valid palindrome here from I to J with K removals.
The IJK? Is it? Oh. Do you like this kind of DP better, or do you like, what is it? This is top down, right? Do you like bottom up better? Or is this bottom up? I actually don't know. Oh, you only use YouTube? That's fair. That's fair.
So basically, if this while loop never breaks.
Parameters of your memory data. I see. Oh, mem data. Mem is top down. Technically, is it not bottom up because you go all the way to the bottom and then you go up? I feel like the naming convention is a little bit, could be interpreted either way. But yes, recursion, yeah, you go top down, I guess.
The last thing we need to do is remember we need to actually return our memo here because we didn't do it earlier and we haven't done it.
But I mean, Meta doesn't ask DP, so it's like, I don't know. Isn't this DP though? Like, I literally says that Meta doesn't ask DP, but like DFS with memoization is quite literally DP, no? Like, I don't know what else to say. Like, well, why am I studying this? Maybe I studied this. I don't know.
Case, the only time we've done it is actually if we found a palindrome up here, or we just did the processing up here, so we don't need to actually go through it again. So what we need to do now is just return.
If they ask me this, the interviewer doesn't even know what they're supposed to ask or not. That's what I would assume.
Memo of I, J, and K, and we should be done. Okay, so that's the helper function defined. All we need to do is actually return the helper function. We need to just return calling helper function from 0 all the way up until length of self.string -1, because that's the last index, and K. So once we do this, it will go through the logic here and tell us whether or not we actually have a valid palindrome. So let me just clean this up a bit in case we made a mistake. Let me run this. Hopefully I didn't botch anything. Okay, looks good.
Damn, it's a hard question. I don't know. I feel like it's hard. I mean, I don't study DP. This is why it's like I don't think I'm that good at this. But all right, let's try this again. Okay, so def is palindrome, and this will take. I guess this will just take a string, right? A string. We'll just call this cur string. I think that's how they did it. Their helper function. Oh no, they do two-pointer approach. That's right, because we need to do it based on the pointers. Oh my god, bro. It's over, man. It's over. Self LR. Define it inside the main function. I think he put it outside, no? Yeah, he did it outside. But I mean, technically it doesn't matter, I guess. Yeah, I could put it inside. And that way I could just get rid of the self. I don't think it matters, but this guy did it outside. I don't know. I don't know. I feel like outside of an interview setting, like you would actually, I think, want to have this separate. But whatever. That's like whatever. I don't think it really matters. Whatever. It's fine. So we have our LR, right? If we have our LR, so then we just say while L is less than R, then return true. And if S of L is not equal to S of R, return false. L plus equals 1 or minus equals 1. That's fine. Memo string bool while L is less than R. Okay, so let me redo all of this stuff. I don't know what I was thinking here. I guess it's just wrong, but all right, we have a helper function now. So, or we need to create another helper function, right? So we'll just call this DFS. Where we are giving it the I or the L R K, right? And we could return the DFS of 0, length of S minus 1 and K, right? And from here, we are saying, right, like what's our base case for our DFS, right? So we can, we also need to make sure we have a memo dictionary. And from here, so we can say if, and we're storing the IJK. So in the memo, we store IJK to bool. This is going to be our key value pair. So if IJK in memo return memo of IJK. Elif, the other case is K is going to be equal to 0. So then if K is equal to 0, then memo of IJK is equal to self dot is palindrome of no, why am I saying IJK? GG. Oh, because IJK is all, I'll just do IJK, F it. Makes life easier that way. Okay. Then we just return self is palindrome of J IJ, right? K is 0. Doesn't matter. If we still have a K, then we still need to process more, right? So in this other case, we have to process until we run out of Ks. So basically, while L is less than R, we need to increment both pointers by the end of all of this, I think. And we're going to say we need to make the decision to go right or not, or right or left, right? So, but we only do it if S of L is not equal to S of R. And then we do this, right? Do we return? I think we return DFS of I plus 1 J K minus 1, or DFS of I J minus 1 K minus 1, right? The thing I don't understand is why do we return this? How does that make sense? Do we want to return it? I don't understand. Maybe, I don't know. I'll just go with my instinct and say that we return it for now. But by the end of all of this, we should say, I guess, memo of... You store it in the memo... Oh. Like this. We store the result of either choice to memo. Wait, is that right? What is that? He hit the... Oh. Is that true? Do we store it in the memo? I guess. I don't know if that's that intuitive, I guess. I don't know. And you return the mem value at the very last. So again, you just return ijk. And what? You just set this to true at this point, right? Is this right? I can't tell if this is right or not. I forget. I don't know, bro. GG. Oh, it's not LNR. I is less than J. Oh, shoot. It should be I and J. I don't know. Oh, no, they're all I and J. GG. GG. S is not defined. Oh, frick. Wait a minute. How did he do this? Self.string of I? Oh. He created another variable called self.string. That's annoying. Okay, got it. To just be able to access it anywhere. It's not that easy. Okay, got it wrong. Nice. Classic. Do you like Java or Python? I've never done Java, actually. I've only had exposure to Python, JavaScript, C++ in college. I think that might be it. And I don't know if assembly counts, but I did assembly in college too. Yeah, that might be it.
We found a palindrome up here. Or we have I return the helper function.
Return. Why do? Okay. This question is so hard, bro. This question is hard. This question is not easy. Assembly? Yeah. It's the computer engineering days. Why do you return this at the end? Because I created it, I guess. It works. I actually got most of this part down. The thing I don't understand... Oh, I didn't get it right. GG. Alright, still wrong somehow. Okay. Got a 95. Jeez, that's good. That's good. Return mem... Okay, I didn't do that. What the heck? Dude, these returns don't make any sense to me. I don't understand. It works. Why the hell is it so slow? Oh, they did a queue. Wait a minute. What is this solution? Yeah, because we're using recursion stack frame. GG. Wait, so you can create a queue with the pointers with a scene while queue LR cur K Q dot. Okay, same thing. We keep track of the LR and the cur. If the cur is greater than K, return false. Okay, so you start from 0. Okay, we're just adding to K. Okay. While S of L is equal to S of R. Okay. If L is greater than or equal, okay. Otherwise, if we're here, we need to add it to this. This code looks so much easier to write than all this junk. Is it not? Oh my god. Wait a minute. Should I just learn this solution? Why am I wasting time learning that? I mean, I feel like I should get better at DFS though, but like also at the same time, like how the hell is this solution intuitive at all? This is like a genius solution, no? Is this the bottom up solution? This is not even DP, I feel like. Are you talking about this this solution? The BFS one? Or I think it's still DFS though. I think this is still DFS, but it's using a stack instead of the recursion stack. Yeah, I mean this okay, so I'll explain what I understand. So I understand that, like, I think like conceptually at a high level, like everything makes sense, right? Like the fact that, you know, we start at the left and the right, that's like our start. And then, you know, of course you create your base cases and all that. You want to memoize so that you don't do any repeated work. Although the thing I don't understand maybe partially is due to the fact like, oh, yes, I guess there's many combinations, so there will be repeated work. I think it's because like you can either move the left pointer all the way right or the right pointer all the way left, or you can move some in between and everything in between, right? So yeah, I guess there could be cases where you might have some cases where some will be repeated, but that's whatever. That's besides the case. I get that. I get that you need to memorize to repeat to prevent all the repeated work. The thing I don't get is like actually coding it though. Like I actually don't understand like why, like how you're supposed to know to store this result into the memo. And then why do you return? Oh my god, I don't understand, bro. There's like so many things I don't understand. ChatGPT, please be my savior. Can you please explain these returns within the helper DFS function? I have no idea intuitively how I'm supposed to come up with these without looking at the answers myself. It's depressing. Good night, Hilo. Take care. Okay. Given a string s, yeah. Key, okay, check substring, yeah. Okay. Standard memoization, I get that. Now this part, memo IJK. You are not allowed to delete any more characters. The only way to check is if it's already a palindrome. So you check it as a palindrome if it is or not, which makes sense. The core logic. The core logic. Let's break this into chunks. As long as the characters match, I get this. If they never mismatch, you'll exit the loop and return true. Oh, DeepSeek? Yo, should I cancel my ChatGPT subscription? Is ChatGPT a scam? Maybe I should try the other ones. DeepSeek. Why is it in Chinese? Into the unknown. Into the unknown. Is it this one? I thought I created an account. Did I not? Maybe I didn't. What if I ask ChatGPT, what is the best AI chat for coding? Surely it's going to say itself, no? Yeah, I know it's a Chinese company. I heard Claude is good too, actually. Why don't I try Claude? Let me try Claude. I was going to try Claude, but I never did. All right, Claude. Oh, it's slow? You don't like it? Okay. I'll take your word for it. I heard it's good though, no? Is it good though? Like the quality of what it outputs? Alright, let me try DeepSeek. Let me try DeepSeek. Grok? Grok? Are you better than ChatGPT? I'm conversational. I like that. Are you better at explaining code? Compared to ChatGPT? But when I asked for an explanation and never came. That's annoying. Let's see if Grok can answer this question for me. I like how Grok doesn't require you to create an account. What am I working on? I'm just trying to understand recursion because I suck at recursion. Can you please be my savior and once and for all help me understand recursion for everything that is, I don't know, because I can't understand the returns in a recursion for the life of me. I'm here to save the day. ChatGPT does not speak like that. Yo, holy crap, it just finished writing? Why is it writing so much? I think I get it. You calc the value if it doesn't exist. No, I get memoization. I get that. I get memoization. I get the point of memoization. The thing I don't get, like, this makes sense to me. This, if, you know, we return, if we already have it in our memories, cache, whatever. The thing is, like, this. Because this is saying store the result. Store the result of the left or the right, right? Or I guess both. But then here, why do we return? I don't understand this. Oh. I think I get it. Yeah, it's for the previous function calls. It's for these guys, right? Please explain. Okay. I think I finally understand now. Okay. Although it's not that intuitive, I feel like. So what I think is the reason we do the return here is because it's recursion. This DFS in the left and the right direction will always go to the deepest end, right? So this DFS will always, like, technically, we could never hit we could technically never hit this logic, like, below. And this is, like, I don't know. In hindsight, I feel like it makes sense, but, like, to come up with this, I feel like it's very difficult. Because basically, what is it saying, right? If the letters aren't the same, we're going to DFS to the left, right? Which technically, now we created a subproblem, which, let's say, okay, let's just quickly run through an example, I guess. So, like, the same example, right? A, B, C, D, E, C, A, whatever. A, B, C, D, E, C, A. So, the AA, that passes because the letters are the same. So that doesn't apply. Shut up, Techno. And then in the other case, in this B and C case, right? So we now have the B and the C. They're not the same. So we're going to try assuming, why don't we just move our B or our left pointer to the right one? So now we're forced to solve, what does C, D, E, C, A return? Oh, wait, sorry. C, D, E, C return. Right? This is our new recursion call. And then it's saying K is equal to 1. Now, but this is where, like, I watched a video saying, like, with recursion, you gotta do, like, a recursive leap of faith. Because, like, the recursive leap of faith is, like, at this point, you're gonna assume that this just does everything. Like, we just, we'll basically just move the left pointer as far as we can every time and return that result. And so there will be one combination, if it works, where this memo IJK will return true, right? And then that's why once we find this, wait, what? Wait, what? So once we So once we find this, don't burp into the mic. My bad. I do it all the time, by the way. Anyways, so that's the reason why you return here, because we're always going to The thing is, why do we store it though? I guess as we bubble up, we store it, right? Is that the intuition? As you bubble up, you store it. Is that the reason why? That's right. That's right. Like that makes sense. So for any given point, right? We're basically saying, so given an IJK, we're saying if we decrement our k by 1, right? So if we make a choice to move our pointer I plus 1 or j minus 1, if either or of these decisions work, then we're valid, right? Like, for example, the CDEC. Well, technically these are valid, so we would ignore the C's, and now it's just D and E, right? So we remove either D or E. In this case, it actually doesn't even matter, which I think in both cases we would return true. So if we return true or true, then memo of IJK is true, which means we could kind of bubble it up, I think. And then we would literally just return that solution. But the thing is, like, we could also like hit a case where what happens if they're always equal, right? If they're always equal, then we just increment our pointers, right? And then we could hit a case where I guess we'll never memo, like we'll just say, okay, we're good. So we just set it to true. And then by the end of it all, we just return the memo of IJK. I don't know, dude. The thing is, if we hit this case, do we ever hit this case? I don't think so. Right? I think this return is specifically for the case that we don't ever have any. Let's ask Grok. Let's see. Holy crap, this guy wrote an essay. I can't read all this. Recursion can feel like a maze. Think of recursion as a tree of decisions where each function call explores a possibility and return sends the answer back up to its caller. Okay. It breaks a big problem into smaller problems. The role of the return is each recursive call computes a partial answer. Is this substring a palindrome with k removals? Passes it back to its parent call via return. The return statement is like saying, here's what I found for my subproblem. Use it to solve yours. The memo dictionary stores results for subproblems keyed by IJK, so we don't recompute them, making the recursion efficient. There are the endpoints where recursion stops and returns. Oh, this makes sense. This makes sense. Then this makes sense, I guess. Return combines step by step. Okay. This else case, I feel like, is the most difficult to understand. If the characters don't match, we try removing one. Remove S of I and check S of I plus 1. The result is true if either option works, stored in memo and returned immediately. Oh, it's returned for the parent. Is that why? You just return it for the parent? Is that obvious or no? I don't know. Every path in DFS stores its result in memo. A B C D E. Oh, there's a base case return. There's a recursive case return. When S of I passes the result of the back to the caller, this tells the parent whether the removal worked. The final return Huh. Oh, okay. So does that mean, yo, Betsy, yo, I missed you, man. Am I good in 23 days? I don't know, dude. I'm losing confidence. I can't lie. I feel like I'm still seeing like, yo, you tell me. You tell me. I was doing this question. Accounts merge. Do you expect in an interview setting that people know the union find, like a union, like how to implement the union find data structure? Or do you feel like it's just one of, like you said before, like is it fine to just mention it, but you don't have to actually implement it? You just implement the DFS solution for this problem. That's one question. Okay. And then the second question, bro. Yeah, DFS has the same runtime. However, I guess there's like a caveat to it. It's like apparently union find is like practically constant time, but it's still like NK log log NK or something like that. No need to write it if you don't know it. Yeah, I guess so. And like, bro, like I feel like this rabbit hole can just get so deep. For example, like this palindrome stuff. I just recently like learned that, you know, like this palindrome stuff, like some of these time solutions are like n squared, and it's like some of these palindrome questions could be solved with something called the, I'm sure you've heard of it. It's called like the Maneker's algorithm. And it's like, really? Like, is it just one of those things they expect you to just mention and be like, yeah, I know there's this algorithm called Maneker's algorithm, you know, and maybe like I know a high level of what it does or something like that, and just say like, it is more efficient and it's an O of n time solution, so it is better. But you don't even have to mention Maneker's. Okay. Okay. So I feel like I'm going too deep right now. That makes me feel a little bit better. Maybe I'm just like, I don't know. I feel like the bar that I'm setting for myself is like starting to increase for some reason. I feel like it's just, I don't know. I feel like technically it can get so like deep, which I guess is maybe like extra credit, but it's just like, I don't know. I don't even think it's worth the time to like invest. That's true. I mean, I will say like I think Union. Okay, I mean, I genuinely get the gist of Union Find. Like I know it has to do with like ranks, and there's also like path compression that you can implement to like, you know, do some optimization and stuff like that. To I guess help with like the time complexity, I believe. But yeah, that's true. I think I just need to revisit it again. I understand it now. Like I think it was like, I mean, it was the first time I think I've ever had exposure to it, so I feel like it was a bit tough for me to digest. But I'll definitely revisit it like in the next week or the next couple weeks, and try to have it like at least kind of memorized in some way. The rank stuff is not important, but the path compression is interesting. Why is the ranks not important? I thought the ranks are important too. Because I thought the ranks help you to be able to do the finds in constant time, I believe. Or is it actually maybe not? Maybe it's just the parent array. But the ranks, well, I guess the ranks, I think the ranks is more for the, well, yeah, I thought the ranks were to decide which tree consumes the other, or which subtree consumes the other subtree, right? The bigger the rank, you'll merge the smaller one into the bigger one, right? I thought that's usually how it works. Oh, but I don't know. This stuff gets like so deep. I feel like, I don't know. Sometimes it's hard for me to like gauge whether or not it's like too much versus like too little. Yo, like, I don't know, because I genuinely wonder if there are some meta interviewers that genuinely, dude, I actually remember my last phone screen. I literally had a palindrome question. Like literally, quite literally, I had a palindrome question. What is happening? Why is my thing bugging out? I literally had a palindrome question, and what? Wait, let me try to find. Is it this one? It was literally something like this, right? And I said, you could do it this way, where you could basically just have like, you consider the odd and even case. And then the interviewer asked me like, that's good, but like, can you think of a way to like prevent, like not do it this way? I actually wonder what he meant by that. Because I was wondering if he was asking for the Maneker's algorithm. Right? So he was asking for it. But, okay, maybe, do you think he actually expected me to implement it? I genuinely think he wanted me to implement it. I don't know. I didn't get that far because I was just like, I had no idea. I don't know if that guy. You could do it with log n with string hashing and binary search. Was he in? No, he was white. He was white. I mean, I can see what you're saying, though. I can see what you're saying. Wait, you could do binary search with a hash? Well, I wonder if he was asking me to do it in a way that I think he was just asking me. Oh, actually, I don't even know. I don't know. I don't know what he was asking. The binary search plus string hashing for a palindrome problem? I'd be pretty impressed. Dude. But this is what I'm saying. Like, don't real is it really worth my time to go this deep? Like, do I need to? Like, I feel like this is like diminishing returns, but I don't know. Like this looks so try hard to me. Like, what's the point? I don't know. It's not worth your time. That's what I'm saying. I don't know. It's too much. Too much. Too much. He would have expected you to know, but I don't think he expected you to implement. Maybe. I just remember he asked me like, because I think in his head, he probably thought this is like duplicated work. So I think he was just maybe not even asking me to like make it faster. I think he was asking me to optimize this unnecessary duplicated work in a way, which you would only do it if you're doing it for the love of the game. Fair enough. It's fair. It's fair. I mean, if you know what, I mean, maybe at a certain period of time in the future, I think, sure, I could probably, you know, get better and like get deeper with like this kind of stuff. But I feel like, I don't know. It's good to know that you're telling me that it's like, it's above, like more like above and beyond, I guess. It's good to know. Okay, valid palindrome 3. Dude, oh, Betsy also. Yo, do you have any resources? I don't know. How did you get good at recursion? I feel like I still suck at recursion for some reason. I just like I feel like I can always recite the solutions that I see like with recursion, but I feel like when it comes to like having to come up with the solution myself, it's so difficult. Like it's so difficult. I don't know. Like for example, like these returns, I don't ever know like if I would ever think of doing a return. But I guess like these returns, I don't know. I guess there's 3 returns like Grok. I was asking Grok for help. Decomposing the states that matter. Yeah, I mean like I know it's always like base case and then your return base case, whatever. I guess there's always 3 returns, right? In a DFS. You return from a base case. You return to the parent. This is what I learned recently, I think. These returns are returning to the parent caller. And then you do a final return. right? And then it's just above gluing together the substates. Dude, I think I just got to do more backtracking. Yeah, I think I just got to do more problems then. Return at base cases when the value is in the cache and when you need to compute the results for the state for the first time. So this is when you're computing it for the first time. This is what you mean. So you always return in this case. So anytime you compute, so basically anytime you're DFSing or like, yeah, you're recursively calling the function, you always want to return right after. Is that true? I feel like I could draw out the recursion tree. It would just take a while, I feel like, but maybe it's worth it to do. It's just one way of thinking about it. Fair enough. Yeah. I guess it just comes down to like truly understanding what's happening within each sub decision, right? It's about how you structure the code. DFS state to answer. Like for me, I feel like the template that I always have in my head is always just like DF, like base case. Then what are the sub decisions? Like decision tree basically. And then I guess final return. I don't know. I feel like it's mainly just these two things. If state is a base case, you know, yes, base case is obvious. And then if state's in the cache, yes, that's obvious. Otherwise, do what you need to do and get the answer. That makes sense. But like, man, I don't know. For example, like, I don't know if I would have, like, if I didn't see this solution, I don't know if I would have known to do this, like, memo ijk set this equal to true. I guess. I don't know. I'm having trouble visualizing it, but maybe I just need to walk through it. Yeah, I have to do more problems. But that's the thing too, though. Like, meta is not asking DP, but this is quite literally DP. But why is it in the meta tag list is what I don't understand. Oh my god. This is why I suck at it, is because it's not asked, it's not expected out of meta, but like they ask a DP question, and now I feel like they don't ask DP, but they will ask recursion plus memoization. Yeah, is that not DP? Is that not DP? I don't understand. I thought memoization was DP. Oh, the bottom up. That's fair, I guess. I think I might have to dedicate like a day or two to just go through all tree like DFS problems or something like that. I don't know. I don't know if there's ever gonna be a day where I feel like DFS just clicks. I feel like I've been doing this for so many. I mean, not that long, I guess, but I feel like DFS is just it's not been a topic where I feel like I'm like confident. It should really be restated as they don't force you to write bottom up. That would be more useful, I guess. Cause I mean, but it does seem in general though they don't ask DP at all though from this list so far. I feel like that was actually like the first DP question I've actually seen, which is why it's annoying because it was a hard question and I've not gotten that much exposure from this list. And the fact that this is the first one, it's makes me a bit triggered, but it is what it is, I guess. Hi, Jake, or whatever. I'll just. Can I type? IJK memoization with DFS and palindrome helper function. They asked backtracking as well, which I think people also tend to have problems with. Yes, backtracking, that's true. I feel like the difference with backtracking is that you just have to like undo the decision after you do your recursive calls, right? Is that like, that's like the main difference with backtracking, I believe. That's it. Yeah. Like, I understand the high level, like, I understand conceptually what these patterns are supposed to do, but like when it comes to actually implementing it and like truly understanding like what the recursion's supposed to look like, I guess in code is the hard part for me. I don't know why, but it's at the same time, I feel like I don't grind it that much. Maybe I just need to spend more time grinding it a little bit more. It's fine. Everything is fine. It's getting late though. I need to end. Frick. I feel like I didn't make as much progress as I wanted to, but I mean, I did learn some new things. Like I learned Union Search. And I guess I'm learning frickin' DP again. Which is good, I guess. I'm gonna definitely have to dedicate some days to just... If I ever get asked S to I, I'd probably just dip. What do you mean? You've solved every question. Why would you have any why would you have any problems at this point? Wait, what question is that? Oh, A to I. What is this question? Implement the A to I function, which converts string to a 32-bit signed integer. Ignore white space. Determine the sign. Conversion. Rounding. The fudge? What the hell is this cancer? Not worth the time? Okay, so it's not even worth my time to try to figure this question out. Should I just look at the answer? Yo, the fact that companies ask this question is... Alright, bro. Yo, they got it, bro. Whatever. Dude, I suck. I don't know. I feel like I suck at this stuff. I don't know if I feel like I'm getting better at this. At a certain point, I start to feel like, dude, I just feel like I'm just looking at the answers every time. Like, I cannot figure out the intuition. But at the same time, I feel like I'm seeing new patterns I've never seen before. And all the problems that I've done so far, just discouraging in a way. But I guess, like, I haven't even done that many. I've only done, like, 60, almost 70 now. Maybe 70. I don't know. At this point, I think I'm just going to stop at 100. What do you think about that, Betsy? I think I'm going to just stop at 100 and just speed run the top 100 and memorize the top 100. Like, legit, from the back of my hand, I could look at the top 100 questions and just be like, I know all the solutions in and out. Of course, still having to understand them, but I'm crashing out. I am. Like, this stuff makes me depressed. It makes me depressed because it's just like, dude, I'm grinding and like, I feel like I should feel some sort of progress, but I don't feel it. But I don't know. I'm sure there will be maybe a certain point. I think I just need to do more questions though. I still feel like this is not that many, to be honest. It's like rookie numbers. Who said I was crashing out? Oh, it's just YouTube. I think it's natural. Yeah. It's because I accept what I don't. Even systems design, I don't know how far I have to get deep with that stuff. Like, oh my God, I got to learn SQL. And it's like, I don't even use SQL for my work. I use GraphQL. It's like, dude. Apparently, most solutions should be using SQL anyways, because SQL handles a lot of nice stuff. Like, they got a lot of nice stuff from what I was reading. It's just like, bro, I have so much to study. It's like, I don't know how much they're actually expecting out of me. There's just too much information to study. It's over. It is over. It is over. It's over. All right, whatever. But today ends and there's always tomorrow. So I will come back again tomorrow, chat, and I will stream again tomorrow. I don't know if I'm going to stream my systems design study sessions because I don't know. Maybe I should, but yo, chill. Yeah, I'm chilling. It's okay. Tomorrow's a new day. We'll let our brain reset and just hopefully download stuff today that I've learned. And yeah, guys, I'll be back tomorrow. So expect some more grinding, and I will try to have a long I don't know if I should do a longer sessions, but I'll make sure I'm more locked in next session. And hopefully we see more patterns that we've seen before. But if we haven't, hopefully we learn new stuff, I guess, if we haven't seen it before, and just keep going from there. Thank you, Hazel. Everyone take care and have a good night. I'll see you guys. Much love as always. And yeah. Peace out.